Hello, my name is Ayush, and in this presentation, I shall be going over my term project, which is on adaptive optimization, adjusting step size by belief. Starting on with the motivation for this project, optimization is something which lies at the very core of machine learning. The learning in ML effectively boils down to an optimization problem, where the goal is to find the best set of parameters that minimizes the loss function of our machine learning problem. This optimization over the loss function uses some sort of gradient-based approach, and the variation in methods to traverse the loss in order to get to the optimal solution has given rise to different kinds of optimizers. In modern day machine learning, popular optimizers are often categorized into two branches. One is the adaptive methods, which consist of uh, optimizers like ADAM that are known to converge fast. The other branch consists of accelerated schemes, which include stochastic gradient descent family that are known to have good generalization. In the paper which I have re-implemented, it has introduced a new optimizer known as AdaBelief, which has claimed to provide fast convergence like adaptive methods, good generalization like stochastic gradient descent family, and training stability. I first re-implement the algorithm for the AdaBelief optimizer, which is very much similar to the Adam optimizer. Here, the intuition for the AdaBelief is that the step size adapts according to the belief in the current gradient direction. We start by finding the gradient GT. Next, we find the exponential moving average of our gradient GT that is given by MT. Subsequently, we find ST, which is the exponential moving average of GT minus MT square. This is the step where our AdaBelief differs from the Adam optimizer. Here, we can consider GT as the observed gradient and MT as the predicted gradient. Next, we do bias correction. This is a step which is similar to Adam. And finally, we update our parameters. Here in the update stage, instead of having VT hat in the denominator, we have this ST hat. Intuitively, we can consider 1 by under root of ST as the belief in the observation. After implementing AdaBelief Optimizer, I test it out by performing various experiments. I start by trying it out on some numerical examples where the optimal points are known. Next, I train models for image classification on MNIST and Cypher dataset. This is followed by some GAN training and a reinforcement learning example. In the first experiment, I have a numerical example of absolute sum function. I have used three different optimizers, AdaBelief, Adam, and stochastic gradient descent with momentum to find the optimal point for this given function. It can be seen from the graph on the left that AdaBelief, which is in green, converges fastest, followed by Adam optimizer, which is in yellow color. The XY plot on the right hand side shows that the AdaBelief optimizer was able to reach the optimal point while the other two optimizers lagged behind. In the next experiment, I've performed image classification task where I've trained multiple models on MNIST and Cypher datasets with different optimizers and compared their performances. In case of MNIST, I've used a simple CNN architecture, whereas for Cypher dataset, I've used VGG11 model. If we see the training plots for the MNIST case, we find that in case of Adam and AdaBelief optimizer, we have a sharper descent in training loss, which leads to faster convergence compared to stochastic gradient descent. However, in all the three cases, we reach high accuracy of 97 to 98% on test data. The difference in performances of the optimizers is much more evident on Cypher dataset, where we can easily see that AdaBelief optimizer converges faster compared to stochastic gradient descent. Even the Adam optimizer has a similar trend as that of AdaBelief. When we check the accuracy on test data, we find that stochastic gradient descent has the highest accuracy of 84%, followed by AdaBelief, which is at 81%, and Adam lies at the last with 76% accuracy on test data. This better accuracy on the test data tells us that AdaBelief has a better generalization compared to Adam, which is somewhat comparable to stochastic gradient descent case. I also trained WGANs using AdaBelief and Adam optimizers and compared their generated images for quality and diversity using FID scores, which was found to be quite similar in both the cases. This tells us that AdaBelief can also be used for generative tasks as it provides training stability for the model. In the final experiment, I compared the Adam and AdaBelief optimizers on a reinforcement learning task of cart pole balance. and the metric which I have used here is mean average reward. In both the cases, I get about 440 average reward with a deviation of 20. This suggests that AdaBelief optimizer can also be used for complex tasks such as reinforcement learning. The final take-home message from this presentation is that optimization is very crucial in machine learning. Although there is no one-size-fits-all solution, AdaBelief is a promising solution for a variety of tasks. With this, I end my presentation. Thank you.